In this third lesson about systems engineering, we focus on the processes necessary to put systems engineering into practice. In the 2015 version of the 15288 standard, there are 30 system lifecycle processes described in 4 categories: agreement processes, organizational project enabling processes, technical management processes, and technical processes. As we go through these processes, I'm going to give a brief list of each in each of the categories. This is a very in-depth topic. The standard uses the following criteria to define the processes. Each lifecycle process has strong relationships among its outcomes, activities, and tasks. The dependencies among the processes are reduced to the greatest feasible extent. And a process is capable of execution by a single organization in the life cycle. The first category is agreement processes. These processes formalize methods of and expectations for agreements between organizations. In situations where groups are in the same organization, less formality may be appropriate. Expected outcomes of agreement processes are common understandings of respective responsibilities of organization, project, and technical functions. This process group contains the following processes: acquisition and supply. Organizational project enabling processes make up the second category. These processes focus on the resources needed to successfully accomplish the project goals. The emphasis is on the environment in which the work is performed. Project processes and lifecycle models in use, decision-making about creating, modifying, or canceling projects, resource availability, including human and financial, that are necessary for a successful project, and measures of project quality from both internal and external perspectives. This process group contains the following processes: the lifecycle model management process, human resource management process, infrastructure management, quality management, portfolio management, and knowledge management processes. The next set of processes, technical management processes, focuses on managing the allocated resources to fulfill commitments made in agreements. The emphasis of this area is on the technical effort of the projects, cost, timescale, and milestones, the alignment of effort with plans and performance criteria, and corrective action planning to overcome project shortfalls. This process group contains the following processes: project planning, configuration management, project assessment and control, information management, decision management, measurement, risk management, and quality assurance.
If you look at who's involved in the early systems phases of a project, that's what I typically call the fuzzy front end. You've got, on the customer side, you've got the customer, the user, the stakeholders who bring a problem and a business perspective. But you also have any number of specialists depending upon the type of problem you're dealing with. If you're dealing with an insulin pump, for example, you'll have biomedical specialists along with electrical engineers and software specialists. If you're dealing with a 787, you're going to have aerodynamic specialists, reliability specialists, etc. Each of those people bring their own domain knowledge gained through reductionist thinking, absolutely essential skills. The systems engineer is really the technical connective tissue that brings them together, helps them communicate about the system, helps them connect their analysis, and helps them deliver the system that ultimately benefits the user in the desired manner.
The final category of processes, technical processes, focuses on tasks at any point of the product lifecycle. The emphasis is on transforming the needs of stakeholders into a product and service. The goal is to realize and apply the processes to create and use a system that meets stakeholder requirements and provides customer satisfaction. This process group contains the following processes: business or mission analysis, integration, stakeholder needs and requirements definition, verification, system requirements definition, transition, architecture definition, validation, design definition, operation, system analysis, maintenance, implementation, and disposal.